Hi everybody, in some of my recent videos I've been talking about image quality and doing some comparisons with lenses and sensors, and then after some new cameras came onto the market with incredibly high megapixel counts, this issue of image quality and image quality limitations are kind of something that triggered some interest in me. And there is another thing I would like to talk about, and that's diffraction, meaning what are the actual optical parameters for getting the best possible image out of a lens sensor combination. So I did a test and I used the Sony Zeiss FE 1.8 55mm lens, both on my A6000 and on my A7 Mark II. Now people will kick in and say, well, it's not, you can't compare them, you can't compare the same lens on two different sensor formats. That's not what I want to show in this video. What I want to show in this video is that there is a defined sweet spot for a lens sensor combination, or actually probably it's more a sweet spot of a lens, and then there are limitations given by the sensor. So if you go below or beyond that point, the image quality will be degraded. And this has to do with the fact that, for example, when we take shots, landscape shots, things like that, some people tend to close down the aperture as much as possible to get the highest possible depth of field, and assuming that they will also get the highest possible sharpness, which is not true, because there's this aspect of diffraction, and this has to do with the light traveling through the lens, through the aperture blades and onto the sensor. Now, I don't want to get into the technical aspects. If you're really interested in that part, you may look it up somewhere else. I'm only looking at the actual application in terms of photography of this effect. So I did two runs on both cameras. One on the let's start with the A6000, because having the smaller sensor with the same megapixel count, and that has also to do with that, because the higher the megapixel density, the earlier and the more intensively this effect kicks in. So let's have a look at the pictures taken with the A6000. So I took a picture with the A6000, and this is taken at the maximum aperture of the lens, 1.8, and it is kind of soft, even though I focused manually and I focused on these antennas or whatever they are, and you see that it's kind of soft. So that we were aware of, and even in the background you see the building. It's sharp. I mean, it's in focus, but it's not very sharp. And even the structure, the surface over here on this cooling thing, device, whatever, you see that it's kind of soft. If you go one up, and we go to 2.8, we see that it's starting to get sharper. And if you look at the antennas, you get it better defined, and this grate gets better definition. If we go one further to 5.6, this is actually quite sharp. Even if you look at the structure down here in the stone, you see that it increases. And this is probably, and you will see now, if we go up to 8.0, the 5.6, somewhere between 5.6 and 8.0, you really have the sweet spot of this lens sensor combination. The structure is probably even better at 5.6, but it doesn't degrade so strongly going up to 8.0. Now, if we go up to 11, you start seeing some degradation. For example, over here on the side, it gets, if we're F11, it gets softer. Then we go to F16, and there it really goes down. And you see the structure here in the stone. Here you see a defined structure, and here it starts getting mushy. And then if we go to F22, this is almost an out of focus picture, but it's not out of focus because it was manually focused spot on this structure here. So there's a huge degradation on this image. So if you use this lens sensor combination or lens camera combination, the best is to stay at 5.6. If you go up, starting, well, basically above F11, it really goes down, and at F22 it's almost unusable. Now let's get to the other pictures taken with the larger sensor on the A7 Mark II. So if we zoom in here again, okay, the ratio is different because it's a full frame sensor, so you don't have the crop factor, but you will still see the same effect, and this is what it's about. It's not a totally scientific experiment, I know that, but since you can see the results and you can replicate the results, I think it's a valid point. So at f1.8, it's kind of softish. It's the typical wide open image, and the background's even slightly out of focus because I was again focusing on this structure here. Then you go up one, and here it starts getting really good, and there you see the superiority of the sensor, because at 2.8 this is already quite sharp. At 5.6, even if you have some moire effects here, and that could be my monitor, but you definitely have a great sharpness here, good structure down here on the stone. This is, again, probably for this lens, this is the sweet spot, 5.6. At 8, it doesn't get any better than at 5.6. I would say there's almost no noticeable difference. At 11, again, maybe a slight degradation, but not yet anything you would really notice if you only had this image. At f16, there is a certain degree of degradation. You see on the antennas here, you see it on the structure down here on the stone. It goes down a little bit, not as dramatic as before, and we're going to have a look at like the same image or the same aperture, comparing the two cameras one to the other. And then at f22, again, you have a substantial loss in quality. It may not be as evident as on the smaller sensor camera, but it's definitely there. So again, I think I can say that the sweet spot for this camera is the 5.68 f-stop with the large sensor camera. It's definitely the 5.6 with the smaller sensor camera. And now let's have a look at the actual degradation. If we take the f22 and the f22 on the other sensor and compare them 1 to 1, and do take into consideration that the perspectives are different, like the sensor size is different. Let me try and see if we can match this up in some more reliable way. Okay, you see, even in the background at f22, everything should be sharp, but if you look at the details, you see that this one is a lot sharper. So the degradation does also depend on the density of the pixels on the sensor. So having the same 24 megapixel pixel count, but on a larger sensor, obviously the density is higher on the smaller sensor camera. Okay, I just realized I will have to clean up my sensor on the A7. But if you look at the structure down here on the stone, and even the grates here and the antennas, it's definitely the effect, the diffraction effect, is substantially stronger on the smaller sensor with the higher pixel density. As I said, this is not a scientific comparison, and it doesn't, pretend to be. It's just to show you an effect that is relevant when you try to get the best possible images, because it's not just stop down and get the sharper images. It works like that up to a certain extent when you reach the sweet spot of the lens specifically and of the lens sensor combination. But going beyond that sweet spot, you will have degradation. Which leads me to another conclusion. When I do, for example, landscape shots and things like that, you may even, or for example, long exposures, it's preferable to stay in the lens's sweet spot area and add a filter rather than going up with the f-stops and degrading the picture quality, the image quality. I hope this is an interesting thing, and actually I will try to do a series of videos with different, and they're not going to be comparisons between two cameras or two lenses, but one camera, one lens, just to define the sweet spot of that combination. Thank you very much. Subscribe if you like, come back if you like, and I hope to bring you some nice and interesting information in the future too. Thanks very much. Bye bye.